Welcome, my friends! Consider the expression x plus 3 times x minus 3. We can FOIL this out by multiplying the x's to get x squared, the x and the negative 3 to get negative 3x, the 3 and the x to get 3x, and the 3 and the negative 3 to get negative 9. The middle two terms cancel each other out, and we're left with just x squared minus 9. Now you may have recognized our original expression as multiplication by the conjugate, the same binomial expression, except the sign in the middle is negative instead of positive. Whenever you have two binomials multiplied like this, the middle two terms will always cancel in the FOIL process. But what if you wanted to go backwards, what we call factoring? What I mean is, what if you had the expression x squared minus 9 and you wanted to go back to the unfoiled form of x plus 3 times x minus 3? How would you do it? Well, take a moment to recognize the pattern between the two expressions, x plus 3 times x minus 3 and x squared minus 9. X in parentheses squared is x squared, and 3 squared is 9. The expression x squared minus 9 is what we call a difference of squares. It includes two squared terms that are being subtracted. In general, a squared minus b squared, what we call the difference of squares, is equal to a plus b times a minus b. Let's look at this formula applied to our example. We have x squared minus 9. That means a equals x and b equals 3. Using the formula, we know that x squared minus 9 is equal to x plus 3 times x minus 3, which is the same expression that we started with. Let's take a look at another example. We have 36 minus x squared. Well, hopefully you can verify that the two values that are squared here are a equals 6 and b equals x. 6 squared is 36, and x squared is, well, x squared. Therefore, using our formula, this can be factored as 6 plus x times 6 minus x. You can verify this is correct by FOILing. 36 minus 6x plus 6x minus x squared, which is 36 minus x squared, as the two middle terms cancel. Now we have exactly what we started with, which verifies that we factored correctly. What about 49x squared minus 4? Our a term is 7x, and our b term is 2, as 7x all in parentheses squared is equal to 49x squared, and 2 squared is equal to 4. Therefore, our final factored form is 7x plus 2 times 7x minus 2, which you could go ahead and FOIL out to check your work if you wanted to. Let's try this one, which has two variables, 64w squared minus 25y squared. Our a term is 8w, and our b term is 5y, so that 8w, all in parentheses squared, is equal to 64w squared, and 5y, all in parentheses squared, is equal to 25y squared. Using the formula, our final factored form is 8w plus 5y times 8w minus 5y. How about 8w squared minus 50w to the fourth? Notice on this problem that 8 and 50 are not perfect squares, so we can't directly go to factoring out by the difference of squares approach. We should notice here that we can factor this expression by first taking out the GCF, which is equal to 2w squared. 2w squared times 4 is 8w squared, and 2w squared times negative 25w squared is negative 50w to the fourth. Notice that inside the parentheses, 4 minus 25w squared is a difference of squares, where a is equal to 2 and b is equal to 5w. This can be factored as 2w squared times, and then we would plug into the formula for our difference of squares, which gives us 2 plus 5w times 2 minus 5w. How about 72x to the third y minus 2x y to the third? Again, we don't have perfect squares here, so we're going to need to factor out the GCF first. The greatest common factor of our two terms is 2xy. 2xy times 36x squared gives us 72x to the third y, and 2xy times negative y squared gives us negative 2xy to the third. Now, the part in parentheses, 36x squared minus y squared, is a difference of squares, with a equals 6x and b equals y. So that means our final factored form is 2xy times 6x plus y times 6x minus y. Okay, let's try something a bit different. Consider 5x squared times x minus 8 minus 7 times x minus 8. We have two terms, which are 5x squared times x minus 8 and negative 7 times x minus 8. Both of our terms have x minus 8, so we can factor out an x minus 8. Then we need to ask ourselves, x minus 8 multiplied by what will give us 5x squared times x minus 8? Well, that just means we need a 5x squared. For the second blank, we ask ourselves, x minus 8 multiplied by what will give us negative 7 times x minus 8? Well, here we just need a negative 7. Altogether, we have x minus 8 times 5x squared minus 7. This type of factoring will come about quite frequently, so whenever you see two binomials, like x minus 8 multiplying two terms, you can always factor that out using this process. Consider 2x to the third plus 3x squared plus 10x plus 15. There are no differences of squares, and there's nothing in common to all four terms that can be factored out. Oftentimes when you have four terms, you might want to see if factoring by grouping might work, which means factor twice, once for the first two terms and again for the last two terms. In this case, just focusing on the first two terms, we can pull out x squared. The inside of the parentheses will be 2x plus 3. For the last two terms, we can factor out a 5. The inside of the parentheses will be 2x plus 3. Now this is the result that we had in the last problem. We have the same binomial on both terms, so it can be factored out. Our final result is 2x plus 3 times x squared plus 5. Let's try 12x to the fourth plus 9x to the third plus 8x plus 6. Again, there isn't any common GCF of the entire expression, but we might be able to factor by grouping. For the first two terms, we can pull out a 3x to the third, which leaves us with 4x plus 3 in parentheses. For the last two terms, we can pull out a 2, which leaves us with, again, 4x plus 3 in our parentheses. Thankfully, the result is the same binomial in parentheses for both terms, meaning we can factor it out. The final factored form is 4x plus 3 times 3x to the third plus 2. How about WU minus 7W minus 3U plus 21? We can factor out a W from the first two terms to get W times U minus 7. We can factor out a 3 from the last two terms to get 3 times negative U plus 7. Uh-oh, it looks like our two terms in parentheses don't match this time. They are close, but not exactly the same. If this happens, change the sign on one of your factors, and that will most likely fix the problem. Factoring out a negative 3 instead of a positive 3 on the second term, we have negative 3 times u minus 7. Now our binomials match, so that our final factored form is u minus 7 times w minus 3. Okay, one last problem. We have 28y minus yx plus 4x minus 7y to the second. In this problem, notice that our last two terms have nothing in common. Nothing can be factored out. If that's the case, you might want to try rearranging your problem so that factoring by grouping will work. We could rewrite this problem as 28y plus 4x minus yx minus 7y to the second. All I've done is switch around the middle two terms. Now, for the first two terms, we can factor out a 4, leaving us with 4 times 7y plus x. For the last two terms, we can factor out a negative y, which will leave us with negative y times x plus 7y. Notice that our parentheses match, but the order is not quite right. Since addition is commutative, we can rewrite this as 4 times 7y plus x minus y times 7y plus x. Our final factored form is 7y plus x times 4 minus y. Alright, my friends, that finishes up our video about factoring using the difference of squares and by grouping.